video, I'm going to show you how to find the particular solution to a differential equation. So in our previous lesson, we found general solutions for the differential equations, meaning that the solutions are infinite because of the plus c. Since we were not able to solve for c and the values of c are infinite, it means that the solutions to that differential equation are also infinite. Okay, and again, that's what we call the general solution. If we are given an initial condition, which is really just an ordered pair, it's a point on the graph of the original function, then we are actually able to solve for c. And if we can solve for c, then we have now found what we call the particular solution. Okay. All right. So here are the steps that you're going to follow. We're really just adding step 4 and 5 to the process. So number 1, you're going to separate the variables. Number 2, you're going to integrate both sides. Number 3, you're going to solve for y. Okay. Then, if you're given an initial condition, you're going to use it to solve for c, and then once you have found c, you can just substitute that value in the equation that you found in step 3, and then you'll have the particular solution. All right, let's look at a couple examples. So here we want to find the particular solution, which will be in the form of y equals f of x to the given differential equation with the initial condition f of 0 equals 3. Okay, so first step, we've got to separate the variables. So I would multiply by the dx on both sides to get y equals negative x times y times dx. And then we're almost there. We just need to divide by y. And so we'll end up with 1 over y times dy equals negative x times dx. Okay, so then we're going to integrate both sides. The antiderivative of 1 over y is natural log of the absolute value of y. Okay, equals, and then the antiderivative of negative x is going to be negative x squared over 2. Okay, and then add your plus c. All right, then we're going to solve for y. So in order to do that, we're going to exponentiate each side. The left side will just simplify to equal y. Okay, on the right side, we're going to have to break up our exponent. And so what we can do here is rewrite this as e to the negative x squared over 2 times e to the c. And then remember, e to the c is still some unknown constant. And so I'm just going to put it in front of the exponential expression. Okay, so, we would have stopped there in our previous lesson. But since we have this initial condition, we can actually solve for c. So in order to do that, we're going to plug in 3 for y. And we're going to plug in 0 for x. Okay, now because we're plugging in 0 for x, that whole exponent is just going to end up equaling 0. So we're going to get 3 equals c times e to the 0 power. And remember, you guys, e to the 0 power equals 1. And c times 1 is just c. So we end up with 3 equaling c. Okay, so then all we have to do is go back up here to where we can solve for y. And we'll just replace the c with 3, and now we'll have our particular solution to that differential equation. Okay, let's look at one more example. All right, so guys, this is kind of interesting because our differential equation is x times e to the negative t times dx over dt equals 1. And our initial condition is x of 0 equals 1. So this is like in the form of x of t. So that really means that the 0 is a t value. Okay, just that's going to be important later when we try to use our initial condition. It also means that we're going to solve this equation for x instead of for y, okay? All right, but anyway, let's start by separating our variables. I would first multiply by dt on both sides. Okay, and then I'm noticing we're almost there, but we want this e to the negative t to be on the right side with the dt. So we can divide by it. So we'll have x times dx equals, okay, initially you can think of it as 1 over e to the negative t times dt. But just to make anti-deriving easier, I probably then go ahead and flip this fraction, which will make it just e to the t power. Okay, so then we're going to integrate both sides. Okay, antiderivative of x is x squared over 2. Antiderivative of e to the t is e to the t plus c. All right, then we're going to solve for x. So first I'm going to multiply by 2 on both sides. We get x squared equals 2 times e to the t plus c. Okay, then we're going to square root both sides. Okay, now finding the general solution, you guys, we would put a plus minus in front. Okay, but based on our initial condition, since x of 0 equals a positive 1, we know that we need to end up with a positive value, meaning that we're going to use the positive square root. Okay, if our initial condition had been x of 0 equals negative 1, then I would have kept the negative square root. Okay. Okay, now what we can do to solve for c is we're going to plug in 0 for t and 1 for x. Okay. So 1 equals square root of 2 times e to the 0 plus c. And then remember, e to the 0 just equals 1. 2 times 1 is 2. Okay, to get rid of the square root, we'll square both sides. 1 squared is 1. Subtract 2 on both sides, and we'll get negative 1 equals c. And then all we have to do is plug that negative 1 in here for c, and we'll have our final answer, which will be x equals the square root of 2 times e to the t minus 1. And that is the particular solution to the differential equation. All right, so you guys will, definitely practice this some more in class tomorrow. So as always, thank you for watching and have a good night.